A rotation is a type of transformation where all the points of the original figure rotate or turn an equal number of degrees around a fixed point. Now, we say about a fixed point, but it also means around that point. So we define the rotation by its fixed point, the number of degrees it's turned, and whether it's turned clockwise or counterclockwise. If nobody tells you whether it's clockwise or counterclockwise in rotation, you always assume it's counterclockwise, which seems counterintuitive. Now let me point out a very common mistake that people often make when they are rotating a shape. If they talk about the degrees of rotation, oftentimes they will say something like a 150-degree rotation. They don't mean from this point to this point is 150 degrees. They mean this point to its corresponding point, which is all the way over here, would be a 150-degree rotation. That's the tricky part of rotation. So let's measure a rotation. If we want to start, we'll start at a pre-image point. Let's call this point my pre-image point. Right here. If I want to measure that degree of rotation to here, I start by connecting my pre-image point to the center of rotation. Then I connect the center of rotation to my image point. This is the angle that I measure. And that angle looks like about 115 degrees. So the degree of rotation is 115 degrees, and we went clockwise. We went this way, about point B. So that's how you would describe rotation. Performing a rotation, or drawing one on a piece of paper, is a little bit harder. To do that, I'm going to start with my pre-image point here. And if I want it to rotate 90 degrees clockwise, I'm going to sketch from the pre-image to the point of rotation. Then I'm going to make a 90-degree turn. And I'm going to copy the same distance. And if this is my point A, here is my image point A prime. Then I would repeat the process with the next pre-image point. For instance, this point. Connect this point, the original pre-image, to point P. Make a 90-degree turn. Copy that same distance. This would be my point B prime. Keep going. Do point C. Eventually, you will get all the way around this shape, and you'll end up with something that's a little bit like that. Of course, it should preserve its size and shape, and I, because I sketched it, did not preserve my size and shape. We can also perform a composition of rotations. Now, when you do a composition of transformations, you're performing a transformation on a pre-image, getting an image, and then performing a second transformation on that image. So if I look at example 1, I'm going to do a composition of rotations. I'm going to start with my pre-image, which is the pouty baby, and I'm going to rotate that image 45 degrees. Now, it doesn't say clockwise or counterclockwise, so I'm going to rotate that image 45 degrees. So the pouty baby image would turn something like this. Now, if I want to rotate it another 75 degrees around the point, I'm going to start with this new image that I've made, and I'm going to rotate it. If I rotate the pouty baby 75 more degrees around that same point, right here, the total number of degrees of rotation from the original image, in other words, this pre-image, to the final image is just the addition of the two rotations. So the final rotation of that composition of rotations is 120 degrees. Now, it's always true that you'll add them unless you're rotating clockwise and then going back counterclockwise. Then you will subtract. Now, in our last lesson, we looked at a composition of translations. So if I translate this point right there by this vector 4, 5, I would go 4 to the right and up 5 to get my next point. So if this is A, this would be A prime. That's my image point. Then if I translate it by the vector -3, 2, I go 3 to the left and up 2 more. This would be my A double prime, or my second image point. Then I'll translate it by the vector -3, 0. This is A double prime, my or triple prime, my third image point. If I want to know the total amount of slide, or the total translation right here, I'm just going to add all of these points together. Add all of the X translation points together. That's going to be -2. Add all of the Y together. That'll be 7. So I can take the shortcut. I can describe the final translation of this composition of translations as 2 to the left, up 7. Again, you're just adding those together. I can also perform a composition of transformations when they're not exactly the same. For instance, I can do a translation and then a reflection. And I'm going to look at this as a line of reflection. And I'm going to start with this bird. If I slide this bird over to about there, and then reflect it over this line of reflection, I'm going to get this white bird. That's a translation followed by a reflection, also known as a glide reflection.